Hey, let's do some math.
All right, let's talk about how to solve a problem like this. First of all, you might try to factor it, but you notice there's no greatest common factor. It's not a quadratic. It's not 4 terms, it's 3 terms. So probably the best thing to do is to use something called the rational root theorem. So I'm going to be looking at this term and this term. So I have n for numerator. So the rational root theorem has you create some fractions that are going to be possible rational roots to this equation, or solutions and roots to this equation. So I use 3 for the numerator. That's because of this 3 right here. And I write down the factors of 3. Well, they're 1 and 2. The denominator is going to be made up of factors of 8, which would be 1, 2, 4, and 8. And then what I do is I form fractions using these as the numerators and these as the denominators. So notice I'll do 1 over 1, that's from here, and 1 over 2, which is this, and 1 over 4, which is that, and 1 over 8, which is that. And it's going to be plus or minus on those. And then I do 3 over 1, 3 over 2, 3 over 4, and 3 over 8. That's where these came from down here. And so it's plus or minus on those. So this rational root theorem was devised to show not which ones are definitely roots, but the possible rational roots. So the way you find out which one of these could work, or if there's more than one that works, is you use synthetic division. Well, this is positive or negative 1, positive or negative a half, positive or negative 1/4. And you try all those using synthetic division to do that. Here's a little refresher on synthetic division. So I'm going to try, and you can try whatever you want to first. I'm going to try positive 1/2. So what I do is I write down, because this is the leading coefficient, that's an 8. And then you have 8 for 8 squared. And then you don't have an x term, which means you need to put a 0 as a placeholder. And then you have negative 3 up here, which is going to be this negative 3. And you do synthetic division. So you bring this 8 down. Half times 8 is 4. 8 and 4 is 12. 1/2 times 12 is 6. 6 and 0 is 6. 1/2 times 6 is 3. Those add together to be 0. If you get a 0 remainder, it means this is a rational root. So I knew that ahead of time, so I kind of cheated. I graphed it on a graphing calculator, so I didn't have to try all of those before I found one that worked. If you do every single one of these, there's only one that's going to work, and that's positive a half. So that might have taken me a while to figure that out. So positive a half is a rational root because I got 0 as a remainder here. So this is how you do the rational root theorem by hand and how you begin to solve this problem. Now the way you would solve this the rest of the way out is you would create a polynomial here for this. So this is 8x squared plus 12x plus 6 equals 0. And you would solve that using the quadratic formula. I've done that on another video, so I'll have you look there. Another way you find the possible rational roots, a quicker way, if your teacher allows you to use a graphing calculator, you can take this and type it into a graphing calculator and then graph that. If you graph, you see this. And what we're doing is we're looking for an x-intercept. Well, it looks like there's one right there, and it looks like it's a half. In fact, I know it's a half because when I did synthetic division here, it was a half. But let's say I didn't know exactly what that was. What I would do is hit second and table set to fix my table. And I'm going to delta table is what you set it to change how your x values are changing in your chart or in your table. And instead of going by ones, I want to go by 0.5. And this has the table starting at 2.5. So now if you hit second and table, you'll notice that the x values are going up and down by 0.5. And you'll notice here at 0.5, you get a y value of 0, which tells me that 1/2 or 0.5 really is an x-intercept. So I was right. That kind of looked like it was 1/2. And this is saying that it really is 1/2 because when I look at the table, I got a 0 when x was 0.5. So you can change those. You can change how those x values are changing. You can adjust how those x values are changing. Usually my calculator's set on 1 unit, so it would go like, you know, -3, -2, -1, 0, 1, 2, 3, it'd go like that. But I changed mine to 0.5 by hitting second and table set, just so I would have a clearer picture. Notice if I had just been changing by ones, I wouldn't have noticed this because it wouldn't have shown up at 1, but it showed up at 0.5. And then once you get one of them, you divide with the synthetic division down here to come up with a quadratic. Like we said a while ago, this is 8x squared plus 12x plus 6 equals 0, because 1/2 was a solution. Then you do the quadratic formula on this to find the other answers, and they're going to be imaginary. So I have a video on here about solving a tough cubic equation where I solved this quadratic. So I'm not going to do that right here. This video is really just to show you how to find one rational root. See ya.